All right, we're up to lesson 12 of Unit 3. We're going to go more into this concept of imaginary numbers and complex numbers that we talked about yesterday. Remember, imaginary numbers are based on the fact or are based around the idea that the square root of -1 is equal to I, different from our traditional real number system. A complex number is a combination of a real number and an imaginary number. So you can see I put a few examples here: 3 plus 4i, -2 minus 7i, 1 minus I. Each of those numbers has a real number and an imaginary number. In other words, a regular number and an I term. So today we're going to just talk about some basics of complex numbers and imaginary numbers. First, adding and subtracting complex numbers. Adding and subtracting complex numbers are going to be pretty much exactly the same as when we did adding and subtracting polynomials back in Unit 2. So to add complex numbers, we're going to combine the like terms, just like we did with polynomials. So we'll add or combine the real numbers. We'll combine the imaginary numbers, the quote-unquote I terms, and that's how we add them. And for subtracting, we'll do the keep, change, or keep, flip, change, KFC, whatever you want to call it. But basically, you keep the first one the same, change subtraction to addition, change all the signs in the second one, and then you combine like terms like you normally do. So that's really the basis of our lesson today. So the first few examples are about that. So let's quickly look at these examples. We're going to add or subtract the following polynomials. So the first one here, again, we combine like terms, which means I combine the real number parts and I combine the imaginary number parts. So my real numbers are 2 and 10, which I underlined in red. So those combine to 12. And then 3i and 5i becomes 8i. So my answer is 12 plus 8i. That is literally it. Okay. I'm going to jump ahead to number 3. And I'm going to do the same thing. We have two complex numbers that we're going to add by combining like terms. So the real number, so I have -5 and +1. That's going to become -4. And then I have -6i and +1i. So -6 and +1 becomes -5i. Put that together, I have -4 minus 5i. So those are the adding ones. The subtracting ones, we'd have to do that keep, change, or keep, flip, change, KFC. So for number 2, remember, we keep the first one the same. We change subtraction to addition. And then we change the signs in the second one. So 10 becomes -10. And then 5 positive 5i becomes minus 5i. Okay. And then same thing in number 4. All right. I'll keep the first one the same, -5 minus 6i. Okay. Change subtraction to addition. Okay. Change all the signs in the second one. So 1 becomes -1. And plus I becomes minus I. plus I becomes minus I. And then we will combine like terms like we normally do. So on number 2, I have 2 and negative 10. And then I have 3I and negative 5I. And if I combine those, 2 and negative 10, 2 and negative 10 is going to become negative 8. And 3I and negative 5I, 3I and negative 5I is going to become negative 2I. So I end up with negative 8 minus 2I. Number 4, okay, I have negative 5 and negative 1. And then I also have negative 6I and negative 1I. So if I combine all those, negative 5 and negative 1 becomes negative 6. And negative 6I and negative 1I becomes negative 7I. So put that together, I have an answer of negative 6 minus 7I. The second part, the last part of our lesson, is finding powers of imaginary numbers. We started talking about this yesterday. Okay, we want to first use our definition of exponents. We also want to use the fact that I squared is equal to negative 1 as a way to simplify the expression. So you might remember number 5 is very similar to an example we did in the last lesson. 5I, the imaginary number 5I squared, what that means is to take that number, okay, squaring means to take that number and multiply it by itself, which means 5I times 5I. And if I multiply that out, 5 times 5 is 25. And I times I is I squared. Normally, we would say we're done here, but we have to use the fact that I squared is equal to negative 1 in order to simplify this. So 25 times I squared is really 25 times negative 1. So 25 times negative 1 is negative 25. So that is the overall answer. So we did a couple like that yesterday when we're squaring an imaginary number. What happens if we cube an imaginary number? That's a different story. Something interesting happens there. So 2I cubed, when you cube a number, that means to multiply that number by itself 3 times, right? So 2I cubed means 2I times 2I times 2I. 2I multiplied by itself 3 times. And if I multiply that out, 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. And I times I is I cubed. Okay? So I end up with 8I cubed. Now, we know that I squared is equal to negative 1, but we don't know anything about I cubed. So in order to simplify this, I'm going to kind of break things apart a little bit. I want you to see what I do here. I'm going to rewrite 8I cubed like this. Watch what I do. What did I do here? So I broke apart 8I cubed as 8 times I squared times I. If I multiply out 8 times I squared times I to the first, do I end up with 8I cubed? And the answer is yes, because I squared times I to the first is I cubed by our rules of exponents. Okay, so to simplify this, I break apart the I cubed as I squared times I. And the reason I do that is now I can use the fact that I squared is equal to -1. So I can make this, I could simplify this as 8 times -1 times I. So 8 times -1 times I is -8I. And that is our answer. So on your cool down today, you're going to see an example like this where you cube an imaginary number. And the way we do that is we have to get a little creative with how we break apart the cube term. So I broke apart the cube term as I squared times I, which is perfectly legal because those are equivalent expressions. And that allowed me to use the fact that I squared is equal to -1. That is it. That is it for lesson 12.